Hi, welcome to class. In the last video, which I'm linking up right now, we considered the I and j vectors. Now, this is a unit circle, and that's why this one has a 1 here, and this one has a 1 here. Now, remember we said that if I were to rotate clockwise 90 degrees about the center, then I would have come to this point here, and its new coordinates will be 0, -1. And then j, after a clockwise rotation about the center, would have become j prime, which is 1, 0. This time around, we want to consider when the angle is not 90 degrees. So let's say the angle were theta, for instance. What will a particle at this position here, after rotating now up to a certain point here, which means would have rotated about an angle, say theta. We can call that a particle P, xy. What then happens to the x and y coordinates? This is what we want to figure out. Now remember, this is a unit circle, which means this particular length here is just 1 unit. If we call this length here x, and we call this one here y, we can begin to look for what x and y would represent. So obviously, y is opposite the angle, so we use so, which means that sine theta is y over 1, which means sine theta equals to y. And in the same vein, because x is adjacent, we use cos, so cos theta will be adjacent over the hypotenuse, which is 1. So cos theta equals to x. The only thing we will want to add to it is, since y here is facing downwards, we know that that downwards part represents this negative y-axis, which means that y equals minus sine theta. So for the first column here, our x value will now be cos theta, while our y value will be negative sine theta. If we do the same thing to j, now let's consider if we were to make an anti-clockwise rotation such that a new particle from I would have moved through an angle theta, and then we can form a right angle triangle this way. In that sense, this place here will be x and this is y. Now to find the value of x, remember that that is adjacent, so x there will be cos theta. Remember that this unit is 1, that's important. And y here, because it's opposite, we'll say y is sine theta. So the very first column here, we then read cos theta, sine theta for an anti-clockwise rotation. Next, if we were to rotate a particle P that has traveled through a certain angle, say theta, we can make up a right angle triangle like so, and this will be the value of x and the value of y. Remember that the x is pointing towards the negative x-axis, so the value there will be negative. Now this obviously is opposite, so we're going to have negative sine theta for the value of x there, and for the y is adjacent, we're going to have cos theta for the value there. Hence, this matrix here represents, for any angle theta, the rotation matrix for an anti-clockwise rotation about the center. To check if this is correct, remember that an anti-clockwise rotation of I and j, remember, gives 0, 1 and -1, 0 for 90 degrees. So all you just need to do is replace theta here with 90 degrees, and your calculator should help you figure out that this is exactly what you get. So please, these are important results, write them down. This is where we're going to stop right now. If this video has been useful to you, don't forget to hit the like button and subscribe to the channel so that you get the latest videos as soon as they're out. See you in the next one. Bye.